that was basically looking at the Hungarian state of play of nature-based solutions. And everything is coming together sooner or later. Perfect. So here I'm representing actually a quite bigger group than that. We just prepared this material for this conference. And yeah, I forgot. Sorry. So yeah, and we had also a consultancy from the Ministry of Innovation and Technology, which was a great help, and we also hope to get all these results into policy on some time soon. So if we look at the background, this is a heat map of, not heat map, this is a Budapest, well, sort of heat map, but it shows the loss and growth of green spaces in Budapest between 1992 and 2015. So we have effects of climate change in Hungary. Hungary is situated in Eastern Central Europe, continental climate, and it is shown that probably we are mostly affected by climate change all over Europe, which is really frightening for us. But we have to do a lot of things about it. So we have, first of all, the effects of climate change. That can vary throughout the country, and then we have the topography and the settlement fabric that is overlaying that is like the next layer of our study. So we have exposure from climate change, and then we have sensitivity based on the topography and different kind of settlements we have. And then we have a social environment, which gives us actually the vulnerability of how people could react to climate change in different kind of housing circumstances, in different kind of urban built-up environment, etc. So when we have all these aspects covered, then we tried to focus on basically two things. The first was nature-based solutions, and of course we have to add also education, because when you don't have anything to do on the hardware side, you have to change the people's sort of mindset. That is what actually we do on a daily basis in our professional life. And that gives us adaptability and resiliency, but well, we are focusing on nature-based solutions today here, mainly. So this is the map of Hungary, and of course, as we heard many times in the last 2 days, we have two aspects of climate change to focus on: heat, stress, heat, temperature, and water. And we have two problems with water: if there is too many, or if there is no water at all. So we always have problems. It only changes with the seasons. So we have seen several studies, models, measurements, everything, and we saw that there is a huge increase in the maximum values of summer temperatures, increase in heat stress, the length of heat stress days, and we know that mortality grows after the fourth or fifth day of heat stress, because that is when our whole system is totally fed up with the situation and just cannot go on with that. And then we have a rainfall. We looked at the precipitation, where models are much more diverse. I mean, they don't really agree on their own results. But actually, what is more or less agreed by scientists is that not the average yearly amount of precipitation will change, but how often we have rain and the intensity. So we will have probably more longer drought times, drought periods without any rain. And if it is during summertime when crops dry out, then it is really a threat on also food chain and etc. And we will have also very intense rainfalls during this spring and autumn period, but now we had a very rainy summer, so we would have like a really strong storm every 10 days in the summer, and we had a very strong storm 3 weeks ago that wasn't experienced in the last 70 years probably in Hungary. So this is the climate change. And if we put topography, then we are going to actually find that the most exposed areas to drought and, of course, water, flash floods and flooded areas is the same. So they are overlapping. So we just have to learn how to cope with it and how to store water, basically, which is really difficult in urban built-up areas. So, but everywhere else it is difficult. But yeah, this is actually the good news in the bad news, or yeah, maybe it gives us hope that at least areas are overlapping. Summing up the environmental risks, the National Climate Change Strategy identified different kind of things that I have already mentioned. And here we have a very interesting Hungarian setting of municipalities and settlements. More than 3,300 municipalities all over Hungary, which is a very fragmented system. And 2/3 of the population, or nearly 2/3 of the population, live in smaller towns, and even then with a population less than 10,000 people. So their economic potential is really very difficult to achieve. And they don't have money on investing in infrastructure. And for instance, Budapest sewage system is 170 years old, and it hasn't been changed basically since the time it was built. And if we put the geomorphology and the settlement system together and the climate change, we will have most likely extreme weather events we would have in these areas. So we basically made up two categories: the upland and hilly areas, which are dense, small villages. They have good ecosystem services, but they are hit by flash floods nearly every year, twice or 3 times at least. And then there are the lowlands, when they are very spread settlements, and basically agricultural areas, so a modified green infrastructure, negligible ecosystem services. But again, they have floods, droughts, heat stress, heat waves, inland water, and the very, very strong soil water level degradation. The level of the soil water is decreasing really frighteningly in the last few years. And here are our results. This is what actually we created after all this background work we've done. We made different types of settlements. We came up with different types, and then we examined what NBS can be applied. Oh, sorry. Yeah. Oh. What NBS can be applied, and what expected benefits we could have if all this is done and implemented. Of course, we identified challenges, objectives. So here is an example for hilly loose settlement. So it must be a spread out. This is, for instance, the third district of Budapest, which is a very good district, but very hilly, constant problems with stormwater management, etc., etc. Then for a lowland dense urban tissue, we have other type of problems, like probably need of urban rehabilitation. The water management, again, is problematic because of the high percentage of sealed areas. And that's why we identified basically rainwater retention, rain gardens, again, on-site drainage, rainwater management. So basically, rainwater management is focused on in this area. And, well, um, you see, we have a lot of expected benefits here. Maybe this is one of the most difficult settings in Hungary, the so-called, as we call them, komi blocks, which is a, a heavy heritage from our previous system, 50 years, where these flats are becoming more valuable because they have a very low cost maintenance. On the other hand, they have good grain areas around them, but they are very, very unpopular still because their flat system is very, very bad. And it can be at a hilly area, which makes it really nice, but on the other hand, it has a lot of problems. Despite and besides, I have to mention that usually socially they are a very, very vulnerable population, aging people with probably mobility issues. They cannot get out of their flats, etc. So they help really a stronger. They needed a stronger help from the municipality, social workers, etc. On top of everything else. And I would like to finish my presentation with a really good example, because what we are trying to emphasize, not only in this study, but all over in our work, that most of the time simple and very cheap solutions could really change the whole situation instead of very fancy and sometimes expensive solutions. This is Püspökszilány. It's very hard to pronounce, I know. It is about 30 kilometers far from Budapest. It's a small village with 750 inhabitants. And they had serious problems with floods, as nearly all villages in Hungary. Uh, and they decided to do something about it. So they won a live project, and they just made some very, very simple, small scale and cost effective solutions, boundaries, like dams. Oh, sorry. Ah! Sorry, can you fix that for me, please?
Just go back to the slide you're on. Yeah.
Oh, this is once more everything. Everybody will remember that. Oh. anyway, no problem.
There you go.
Okay.
You've got it.
Oh, perfect. So they made really very, very simple things, and all over the catchment area of this small stream. And the good thing was that they didn't only concentrate on one municipality or within the boundaries of the municipality, because these problems can never be solved within the boundaries of built-up areas, although the problem will eventually occur within the built-up areas. Well, they changed the whole face of the earth in this village with these tiny little solutions. And I should probably add that one of these things to build, it's about, the cost is about 600 or 700 euros, which is probably the monthly salary of a minimum waged person in Hungary. So this was really very simple, very cheap, and very effective. So we hope to see that really often all over Hungary in the future. And thank you very much for your attention.
Thank you, Flora. We have, well, Flora is our last speaker. For those of you who came in a bit late, we only have 3 speakers today. So we'll take a few minutes of questions for Flora. And then right here.
You have talked in one of the slides about water degradation. Water degradation.
Water degradation, yeah.
World, in many cities in the world, water is degraded to the level that it is starting emitting methane, and there are explosions in seawater.
Actually, could you please repeat it?
See, water level in some cities have degraded to the level that it is emitting methane and there are blasts in the seawater. Delhi is an example, Karachi is an example, in Karachi, number of people died. In your country, what is the status of this? Is that kind of somewhat weird?
Well, I think I can. Um, here I think that the third point is the answer to your question because you asked about the rain, the water degradation.
No. Water degradation in the city. Due to the building of the city, there
Yes.
is degradation in the wastewater.
Oh.
To the level that the rivers completely spoiled. There is
Oh.
nothing. I have read from that. That water is now open in open emits methane. That is dangerous level.
Oh, it's methane.
So do you have that kind of?
No. Actually, the water quality of natural water is not so good.
No, natural water
but
is very
it
good. There is no problem.
So basically, he is asking about that it is reducing that level that it is exposed to a methane gas, and then it is kind of giving the blast or something like that.
No.
In Karachi, there was a blast, 14 people died. In Delhi, there was a blast, there was 14. These covers of the mail boat, weighing about 50 kg. They were blocked.
No.
This kind of thing.
No. It is not the situation in
This is
Hungary.
a part of my presentation.
Yeah,
You can
actually,
go through that what kind of seriousness we are facing.
no. I think not that level of seriousness.
See, all countries where the population is not very high, there
Yes.
is no problem. But where population is too much, then this problem.
Yeah, no.
And this is, I have talked about disaster in pipeline. One meaning of pipeline is that it is in future. Another is the actual pipeline. There is a lot of methane accumulated, and it may blast the pipeline.
Well,
There are reports of this.
in Budapest, where it is probably the densest
If
city,
you are
and it is
low
hilly.
population country, there is no problem. if it is
But
high
compared,
population,
I think compared to many other places on Earth, we are a very low density population in the country.
For this conference, I suggested that there should be special session on the densely populated.
Yes. However, we had a lot of damage of flash floods, and it is basically because of the sewage overflow. Because the sewage system can take
See,
The-
the densely
the
populated
rain.
countries will be nuisance for the future.
yes,
in-
it is
in-
nuisance for
in-
us.
in-
Yeah, but you know,
See,
I showed the
in my
social.
country, 9 megacities were getting one. One contiguous urban space is 150 by 150.
Yeah. So I think, I showed the social aspect because for everyone, the biggest problem is that he or she, they are facing. So basically, we are facing these problems, so this is big for us. But I suppose for others, it could be something beyond threshold.
Even this one, I heard about the news that some 40 covers of manholes flown into air. I was laughing, but when I saw internet, there were many incidents.
Well, we have some mishaps, let's say, with the sewage system, but not so seriously. Yeah, we're actually Budapest just implemented about 10 years ago a whole and huge biological sewage cleaning system, which works quite well. So since then, Danube is potable nearly.
Thank you. Question here.
I guess kind of what you just said. is anything being done to sort of upgrade the sewage system since it's so old?
Well, yes. The problem is that public utility companies have very limited access to funds, or on national level, because I think the problem didn't really achieve our threshold of problem solving, and because of the European Union stopped giving funds for infrastructure reconstruction about 8 years ago. So it was then said that, okay, we have some time, and now the problem is really huge. And it is a big question on one hand how they are going to solve it, but on the other hand, the good thing is that now public utility companies are really interested in not investing into gray infrastructure, but to invest in blue and green infrastructure. So now they are working together with the ministry. I mentioned in the beginning. So we were actually working together. We had a workshop with all the public utility companies together because they are interested in all this work we have done. And they want to invest in those kind of solutions because if they help and work together with the municipalities, then they can sort out much better solutions on the long term.
So we can take questions for Nisha and Laura as well,
Yeah.
as well as Flora, because we do have some time left. So open question session for any of the speakers.
Okay, I have to remember.
I have a question for Laura. This was a really great presentation. I'm just interested to know what type of rainfall events that you specifically looked at. Was it particular return periods that you looked at, or specific durations? Because I wonder if there's any variation in results depending on what rainfall events you reckon on the activists with the green garden.
Yeah, that's a really great question. For our purposes, we decided to not look at hourly data just because that's a very computationally intensive simulations run. So we mainly looked at monthly rainfall as well as we did a little bit of analysis into daily rainfall. But because of that, we were capturing more of the averages of the rainfall and not necessarily the extremes associated with like an hour by hour, minute by minute storm. So we were looking at the average patterns associated a little bit more with like month to month and seasonality over the 10 year time period instead of, which is, we could be missing some data, of course, like you were saying, by looking at maybe the hourly storms or even just the minute by minute storms. But yeah, so just for this purposes, we were looking at the monthly and then kind of averaging that up as well, just to kind of see what the overall trends were. But that's something we definitely want to see if we can look into in the future, since that's a lot more consistent with current hydrologic studies, is the more event-specific studies.
I'm wondering if you said like the results were that one of them slide.
Yes.
I wonder if you integrate that kind of more on your daily information, you might see more of an effectiveness there with the rainfall.
Right, yeah, and that's a good, yeah. Yeah, I was like, basically, yeah, because we looked, even in looking at the daily stuff, daily also is, 24 hours, so that's also a little bit too coarse of a time scale, and we're seeing something very similar to a monthly, so I think that's something we definitely want to look into and kind of make a priority in the future, is maybe having a shorter simulation, but having it output hourly data so that we can actually maybe capture some of that better, hopefully. But thank you for that. Yeah.
Okay. Oh, here we are. Toby has a question.
Yes. Okay, so I have questions for the three of you. So probably I'll start with Laura, who was the mic there. So yeah, trying to understand, so your work is more about urban runoff, right?
Mm-hmm.
And you're working at 10 kilometers resolution.
Yes.
You talk more about the hydrologic parameterization. You talk about the vegetation aspect, but the urban, I was wondering, like, beyond the impact of the prevailing climate situation, the temperate versus the continental climate.
Yeah.
How much effect does the city size has on the impact of the runoff?
That's a really good question. And I'm not sure, we haven't done any analysis actually accounting for the city size yet. What we were doing was just looking at the average of all of the grid cells that fell within the city boundaries. Because for some of the cities, they were larger, and that kind of meant that they encompassed more grid cells than some of the smaller cities. So that's actually really, I'm gonna write that down. Looking at how maybe the area weighting affects that, since I actually don't know that I have an answer for how the size of the city impacts temperate versus climate.
And I also think overall it would also boil down to you using a more finer scale kind of model, even though if you're going to do like multi-scale modeling, yes, such that you can bring in the effect of the bigger grid and then up to downscale it to a more smaller grid, because these are it's urban runoff, right?
Right, yeah.
So the urban aspect of it has to yeah. So So I can go to Nisha. Yeah. So my question is, so you have this the input section, right? Dimension. And I was wondering, in terms of the implementation of this framework, like how do you actually know where to apply this intervention? Is there any input, or do you consider like thermal inequality, green inequality to determine where? Because so you said if we have a budget to reduce heat stress, then you don't want to apply that budget in already kind of adapted areas already. So you want to look at the right area to actually apply this solution and spend the wise use case of the money. So do you actually have this factor included in your framework?
So to that question, I have two answers. So first, as you told, we are not considering the input parameters or input indicators because the whole project was in several levels. So first we have to do the literature review from what kind of this green roof has how much potential to reduce the heat stress or have precipitation, then green park like small park or big park or different kind of trees, how much potential they have to reduce this heat stress and heavy precipitation. So first we have considered that kind of parameter, and I don't wanted to go into the whole process. So on that filters we have decided this indicators, and to the second answer that the whole process was just here I shown my part, but actually the whole project was kind of discussion with the different stakeholders, and we have two workshops, and in each of them from the different German ministries there were people, around 40 or 50 people who discussed about these parameters, that what should be in a climate adaptation strategies for 2030. And then they kind of figure out these parameters should be in the kind of policy or future developments, and further kind of investigation needs to do for this parameter. So for urban greening, it is lots of work have already done, but still it's for example, in terms of urban roof, like a green roof, we have uncertainty how it functions or how in what condition, what local climate zone it is functioning or not. So this all parameters we have considered, but it is kind of a conclusion of our work, and the whole process was obviously very kind of a bit.
Thank you. So, to Flora, and I also think probably the question I want to ask might also be applicable to you. So, in your case, you have, if I understand correctly, so you have this, let's say, a particular neighborhood facing certain environmental challenges.
Yes.
So you have identified that, and then you have this long list of MBSs to be applied.
Yes.
So my concern is, do you have a system whereby you, I mean, within your framework, whereby you select the most effective, because you cannot possibly apply everything at the same time.
Yeah.
And you want to make the best use of your budget. So is there a system whereby you rank the level of effectiveness of the MBS? And also for you, I think it's also relevant to your project. Like, you cannot, you have rain gardens, you have green roof, you have trees, you have parks and all of that. So is there a system in place whereby you rank the level of effectiveness so you know what to per the hazard you're trying to mitigate or adapt to?
Well, it is a very interesting question. We haven't reached that level in our study, but during our planning experience, we came to the conclusion that it also depends on the place. So usually you have problem in the city center. So we have another city in Hungary with about 30,000 inhabitants, and the city center is flooded under, I don't know, 5 meters of water every year, every 5 years, let's say, or every 3 years. And they have serious damage in the buildings. They have to clean up the area. But other times the stream is, you could walk in it. So it's like 30 centimeters high, the stream. It's so small. So in order to change the whole situation, we were involved in the project development of that planning, rehabilitation of the stream. And we suggested that we go further out. We go to the boundaries of the municipality, and we actually had to only ask, but wait a minute, you have a field here. Why don't you make a huge area that it can be flooded in case of a flooding event? You have to create like multiple places where the water can spread out, and then you have no problem in the center. So usually, it is I think it is every time you have to check the whole catchment area if it is about water, and you have to have a wider and a broader spatial and temporal view of the whole problem in order to be able to find the place and the correct solution to be implemented. And I think it is a different kind of solution probably. Because, well, it could be mainstreamed, maybe in 10, 15 years when we will have a lot of such projects implemented, and then we will have the experience what worked in Hungary and what not. Of course, we could have benchmarking, and we always do benchmarking previously and see what worked in Germany, in Poland, because it's similar situations usually. But on the other hand, the Hungarian situation is very interesting from that point of view. That it is very different in the hilly areas and on the lowlands. So it is sometimes you need completely different nature-based solutions, green infrastructure elements, etc.
Yes, I want to state that the major problem is encroachment into the flood plains of the river. For example, let's say where I live, in the nearby cities, there are buildings, 30-story buildings have come up in those areas. And if 1957 or 1978 flood repeats, these buildings will be washed out totally with the basement, etc. Whatever they put, that will. There is two incidents near Delhi, I have heard, that there was extreme floods. Delhi was cut off from the next cities and to east of it, portion of Delhi that is next town and further. So those people who flew to Delhi and wanted to go just 20 kilometers, they were not able to go because of floods. And now if this year floods you see in the hills, the buildings are collapsing, coming down with that. It is not say one or two buildings, number of buildings, even now the cities are getting lost. The major problem is that if these people start constructing in those areas where the water has to flow, they will get it. And it will take a number of times, but major disaster, this is size of disasters only because of the impact.
Yeah, for us, like that is what we are doing. Like the, as I mentioned, the calculation of green indicator. So it is divided into a 4 parts. So first we are focusing on to like the one indicator. We calculate it. We kind of find the target value. So for Germany, for different cities, we already have that. That for example, there is one is a green share. So how we calculate or how we understand that approach is like with the inhabitants. So with every person, it should be 10 square per meters, 10 square meters
Then it has
square per
per
meter
person.
per person should be there. So it's more like that kind of quantifiable variable will help to understand what needs to be implemented more and how we get that success. About the nature-based solutions and the next part, like the next project is the next step after that. This will be we will focus on the nature-based solutions, but yet we haven't started anything working on that part. Yeah.
Thank you.
Toby, can I just comment? I just wanted to react to what you said. I mean, I come from India, and when you said 10 meters square per person, it's a very quantitative standard.
Yeah.
It's a very area-based standard.
Yeah.
But if you have to look at the efficacy of an NBS, do you think qualitative side also has to be integrated?
That is what that is what the next question comes, that in urban dense areas that it is not feasible to have that kind of solutions. But then there is another parameter called green volume, which is considering the vegetation instead of the per person value. So in vegetation, we are then considering in terms of a 30% vegetation should be there. So if, for example, if we are considering the 100 kilometer of area, then it is kind of needs to achieve that the 30 kilometer of area should be dedicated to the green vegetation. And that is now the next problem, is that in terms of the architecture development, we need to in any way kind of needs to implement this kind of parameters or quantifiable variable, which is kind of one proof studies showing that 330 and 300 rule. So basically you can, I am not sure that you have seen that paper or read that paper, but they are saying that from each house you need to see 3 trees, 30% of the green total volume, and 300 every 300 meter you need to have a park. But of course, for the density or mega city is not a feasible solution. But yeah, that is the next task. How to implement this kind of green vegetation for this.
Vertical greening.
Yeah, vertical greening, green roof are there. Yeah, then kitchen gardens are there. Then other kind of rooftops are there. So that is why we just not focusing on the greenery part, because everywhere it is not feasible to have that. But then we can focus more, like in the densities, we can more focus on the soil sealing or the parameter, for example, the material, that we make more reflective surfaces or rooftops, which also have the potential to reduce the temperature until 2 degrees Celsius or something. So basically, it is local phenomena. First, we need to figure out what amount of temperature we need to reduce, and then we need to individually work on the strategies. That is what my understanding is.
Yeah. Yeah. Sorry, I just had an idea that you asked about the quantity and the quality. This town I mentioned, that they have these huge floods. They have, I think, one of the highest percentage of green space per person, because it's 48 square meters per person, which is really impressive. So their problem is not the lack of green space, but now we are working on a green infrastructure strategy to enhance the quality even more, or maybe focus on food production, food security, etc. And the other one, you asked the most effective solution. Sometimes the answer is in very detailed hydrological modeling, and you just cannot avoid that, and it is very expensive. It takes a lot of time, but yeah, you have to do it because it gives the answers.
I feel that cities in India are much better labs for conducting research on carbon trade. The temperatures above 50 degrees centigrade, that's environmental temperature. There are, say, heat islands within heat islands because of congestion, housing, the population density, then the condition of water resources. So it appears that we have data on these extreme situations. See, what she talks about flood, and if I compare it with floods in India, that is much more devastating. I had one suggestion that one of the conference, at least next or next to next, should come to India. And I take the responsibility of conducting.
Yeah, it's not that hard. I've looked at that.
Except-
They have points.
Yes, and not only that, this is a heaven for tourists. To travel at very low cost, to live at very low cost compared to developed countries.
So basically, we can solve the problems in India. We can solve
I
everything,
shall
right?
bring the cost of one person to 1/5. Just 20% cost. And I shall give you much more comfort. In the say 5-star hotels, and when food will be easily available, it will not this kind of condition. So you will have not to pay anything for the high quality. So you conduct it 5 days, 10 days, and enjoy the pleasure. See, it is not only Taj Mahal. There are several thousands of buildings constructed some, say, maybe 1,000 years ago. They still survive, and they're beautiful architecture. They're beyond imagination. See, when I saw those details, even I was astonished seeing that.
Yeah, so tomorrow there's a session, I think at 5 o'clock or something, about the future of ICUC and AUC and making it more inclusive to places like India.
I
So
can
your comments are
I
perfect.
can make
for that.
5 presentations.
Please do. I think it's wonderful. So, any comments from the back of the room? We've been concentrated in the front 2 rows here. We still have time, and I have one more question, but anything from the back before we wrap up? Nisha, you did a systematic literature review about climate adaptation framework. So I'm just wondering if you could say a little bit about your literature sample, and if there was a geographic bias, or what was the size of your sample?
So you mean in the number papers?
Yes, and this geographic distribution.
Yeah, so basically first we, like the project was about the Germany. So first we have done the literature or the report survey for the Germany, but like the result, this preliminary result which is right now is for the Germany, but the next task is like we are writing a review paper, and in that we are considering the whole globe study. So in that we will have the more information about this 7, and even we are considering more indicators than 7, which are globally kind of affecting or needs to be considered.
Okay, so shall we wrap up? Thank you everybody for coming, and thank you to our speakers. Both those were very fascinating presentations and challenging questions from a lot of people, so you did well. Thanks everybody.
Thank you.